reactions today. So today we are doing what is called reduction dash oxidation. So reduction dash oxidation reactions, aka redox. Because reduction oxidation feels like a lot of words to say. So we usually just call it redox. So here is how this works. We're going to write out an unbalanced equation. Are you ready for this?
Yes.
V2O3 plus H2 yields VO plus H2O. Do you guys do this in IB?
Yes.
Okay. So before we do this, there are some rules that you guys have to know. So the first step is assign oxidation numbers. So step one is to assign oxidation numbers to every atom in the equation. So here are a couple rules to remember as you are assigning oxidation numbers. For example, alkali / alkaline metals are always a +1 or +2. That makes sense according to the periodic table, yes? Group 1 is always a +1 because they want to do what with one electron? Lose. Group 2 wants to lose 2, so it becomes a +2, yes? That's what we're talking about here. This is nothing new. Agreed? Okay. Hydrogen. Hydrogen is always a +1. Oxygen is always a -2, except in peroxide. So oxygen is not a -2 when it is peroxide. So put that in parentheses. If it's a polyatomic, then the charges would be given, right? Charges would probably be given. And if it is an elemental form, it is always a 0. So those are the constants, things that never change. Alkali, alkaline, +1, +2, hydrogen +1, oxygen -2, except peroxide. If they're polyatomic, a lot of the times the charges will be given, or if it's an ion, they'll give you the charge of the overall compound. And if it's an elemental form, it has a 0 oxidation. So let's do step number 1 for this equation. What is the charge for oxygen? What is the oxidation number for oxygen? 2-. All right. Do we know vanadium based off of this list? No. But we know that all charges have to have what? All compounds have to have what overall charge? 0. This is the hardest part, guys. Okay? This is the hardest part, is making these equal. So what's the charge for vanadium? No. 3+. -2 times 3 is -6. So this has to be a 3+. This is the most difficult part for some reason for AP Chemers. I don't know why. Because it's just math. It's just adding and subtracting. And you're going to be adding negatives, subtracting negatives. Charge for H2? No. No. Elemental form. Would you agree that hydrogen is a diatomic element? Yes. So the diatomic elements, H2, N2, O2, F till Cl2, those would be 0. Everything else, if it was just by itself, like Fe, would also be a 0. But hydrogen is elemental form. Agreed?
No,
Sure.
Because it's a diatomic element. And you'll never just see H by itself. So that is elemental form for hydrogen. You guys okay with that? Good? Okay. Oxygen over here, charge is 2-. So this vanadium must be what? 2+. This oxygen is going to be 2-, which means this hydrogen has to be, and it always is what? +1. +1. So we have done step 1. We have assigned oxidation numbers. Step 2 is determine your losers and your gainers. So determine your losers and your gainers. What'd you say?
Is this Leo and Gar?
Yes. Determine your losers and gainers. So let's put a little star down here and talk about that. Gaining electrons. Gaining electrons is reduction. Underline gaining and underline reduction. Think about that. Does that make sense? When you gain negative charge, what is happening to the overall charge?
Goes down.
It goes down. So gaining electrons is reduction. So you may want to put in parentheses, charge is reduced. Charge is reduced. So gaining electrons is reduction. Losing electrons is oxidation. Losing electrons is oxidation. There's no fancy way to remember that, but losing, you're just oxidizing. You have to know that. There's two ways to remember this. Way number one is how I learned it in high school. Leo, the lion, goes grr. So, how does that help me remember? Losing equals oxidation. Gaining equals reduction. Losing equals oxidation. Gaining equals reduction. So Leo goes grr is one way to remember it. The other way is the new way, oil rig. Oxidation is losing, reduction is gaining. So either one of those is how you're going to do it. Cool? So back to our problem. So did vanadium change charge? Did vanadium's charge change from the left side to the right side?
Yeah.
Yes. So this is how I do it. So I like to just kind of draw a little line like this. Stay with me. And what did vanadium do? Did it lose or gain? It gained. How many electrons? How many gained one electron? Would you agree that 2, yes, gained one electron?
Yes.
Because it went from a +3 to a +2?
Yes.
Are you guys okay with that? So I would say 2 gained 1 electron. For a total of how many electrons? 2 times 1 is?
2.
2.
So 2 electrons. Did oxygen change? Why 2? Because there's a subscript 2. Subscript 2. Did oxygen change? Did oxygen change? -2, -2, -2. No. Did hydrogen change?
Yes.
Yes. Okay. So I'm going to go here over to my other hydrogen. What did hydrogen do? Lost 1 electron. But how many lost 1 electron? 2 lost 1 electron. For a total of how many electrons? 2 times 1 is 2 electrons. Agreed? So is this balanced? Are my electrons balanced? So is this equation balanced?
No.
No. So whenever I have if my electrons are balanced, everything else is just by inspection. Okay? So if I have 2 here, what has to go here? 2. Now is it balanced? Yes. But this is going to actually help you balance equations, as you'll see in a second. So I would say, what was reduced? V was reduced. And I would say, what was oxidized? H2 was oxidized. And how many total electrons were transferred? Not 4. I gained 2 and I lost 2. So 2 electrons were transferred. 2 electrons were transferred. So that is a very, very, very basic example. Let's do it a little bit more complicated. You guys good with this?
Yes.
Okay. So let's do pH 3. So pH3 plus N2O gives me H3PO4 plus N2. Step 1. Assign oxidation numbers. What is hydrogen's oxidation number? Plus 1. So what is phosphorus going to be in this compound? Minus 3. Good. Oxygen is always
Is this H2?
2 minus. That's N2O. That's not H2O.
That's what confused me.
That's N2O.
Yeah.
I wrote
N.
H2 and I got really confused.
That's an N. That's not an H. There's no lower right leg.
It really does look like
My eyes don't work sometimes.
I can see that. It's an N though. Oxygen is minus 2, so that means this nitrogen must be plus 1. So this is different than just looking at the periodic table to see how many it would normally gain. So oxidation numbers are different. This hydrogen is going to be plus 1. This oxygen is going to be minus 2. Here comes the tricky part. Negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. So what does this phosphorus have to be? Positive 5. The hardest part of this, okay, is just adding and subtracting. Charge for N2. 0. That is elemental form. That's a diatomic element. It's a diatomic element. Okay, good. Did phosphorus change?
Yes.
Okay. So, what did phosphorus do? Nope. Nope. Lost 8 electrons. Phosphorus lost 8 electrons. This is the hardest part. Because it went from a negative 3 to a positive 5, so it lost 8 electrons. Fair?
Yeah.
There's only one phosphorus.
There's only one. Lost 8 electrons. What else changed? Nitrogen also changed. And what did nitrogen do? Gained 1 electron. But how many gained 1 electron? 2 gained 1 electron, right? For a total of 2 electrons. Are my electrons balanced? No. So here is how you balance an equation with the redox method. How many electrons do I need to transfer? A total of?
6.
No. A total of 8, right? I lost 8 here, agreed?
Yeah.
So I need to gain 8 on this side, yes? So 2 times what gives me 8?
4.
So I need to multiply this by 4. If I multiply it by 4, guess what coefficient goes in front of this compound? 4. And that gives me a total of 8 electrons. Are my electrons balanced?
Yes.
Yes. So everything else at this point is just by inspection.
Whoa.
So I have 8 nitrogens here. So what coefficient has to go here?
4.
Balanced. That's it. What was reduced? No.
No.
N2 was reduced. What was oxidized? P was oxidized. And how many electrons were transferred? 8 electrons transferred. Why is it 8? Because I lost 8 on this side and I gained 8 on this side. Those always have to be equal.
It's whatever you end up with.
Whatever your balanced electrons are your number of electrons that were transferred. We're going to do another one.
Why is the negative charge first in pH3?
What do you mean? Oh, here?
Yeah.
Because that's more of a covalent compound. So in a covalent compound, it doesn't have to be positive, negative. That's why. And these are also just kind of weird. Are we good?
Yes.
Okay. I don't have enough room to do another one. Maybe you guys do. Yeah, I'm turning the page though. All right. I'm turning the page. We'll let you guys try to spread your wings a little bit. You guys ready?
Sure.
Do you guys just want to try to get your own oxidation numbers this time?
Yes.
Okay. FeS plus O2 yields Fe2O3 plus SO2. If there is no way to tell something, you just go off the periodic table. All right? So if there's no way to tell something, you go off the periodic table. So assign your oxidation numbers first. Let's see if you guys can get that part. We have our nice Quizlet live music in the background. It's our theme music. This is kind of fun because this is a really easy way to balance more complicated reactions. Do you guys have your oxidation numbers assigned?
I think so.
Yes?
Oh wait, it's a yes? What is it?
It's those.
Can I figure out iron's charge?
Yes.
No.
Oh.
Iron is a transition metal. Its charge changes, right?
Oh, that's
So we can't figure out iron. But I can figure out sulfur. Sulfur's going to be what? Minus 2. So this iron has to be plus 2.
That's what I meant.
Okay.
Yeah.
Yes. O2 is
Zero.
elemental form. This oxygen has to be 2 minus. So this iron is 3 plus. This oxygen is 2 minus. So this sulfur is 4 plus. Did you guys get it?
Can you go over the multiplication?
Is that the second one, guys?
Yes. So once I figure out oxygen is 2 minus, right? 2 times negative 3 is negative 6.
Yeah.
So I have to make that 0. So in order to make this whole thing 0, 2 times positive 3 becomes positive 6.
Oh, okay.
So the overall compound has to be a 0. Unless it's an ion, which we'll do that later. Yes?
The O2 and the SO2, you termed it as 2 minus because of our rules from
Because the
earlier?
rules.
Okay.
Oxygen's always minus 2,
Okay.
unless it's part of a peroxide. All right, finish it. Try it. These aren't tricky. It's just adding and subtracting.
Yeah, that's fine.
I know. It's just adding and subtracting.
I'm gonna like add 1 or not add 1.
Adding and subtracting. I like to do 1 on the bottom, 1 on the top. That just helps me keep my mind organized. You wouldn't have to do how I'm doing it. Just how it makes sense in my head. And here's the good thing. You know if you did it right. Right? How do you know if you did it right? It's balanced. Right? You know if you did it right. Because it'll be balanced.
Because there's 3 oxygen. Do you have to go to both? Because the 2 are matching. Do you just have to?
This wasn't a good one to have you guys do on your own.
I got some stuff.
My bad.
You have to run one
That's
to
a
the
lot of
other?
Let's do the easy one first. Okay?
Because I'm over here like, got
Sorry.
lines going.
Sorry. Not a good one.
I got like branching brackets.
That's actually right though. I have branching brackets on mine too.
Oh, perfect.
What did iron do?
They lost.
It lost 1 electron. Now oxygen,
What do you do for the two?
But 2 games.
hold on. Oh, lost 1.
2 lost.
What do you mean?
2 lost. Because there's a 2 on the end.
No,
I think so.
nope. It's only the left side.
Oh.
All right? We only go off the left side. All right, it's all depends on the reactants. This only lost one electron. One lost one. This side's just gaining. I don't care about what's being gained. I care about what's being lost based off of the reactants. Oxygen, does it change?
Yes.
It changes here, but it also changes here.
What?
Okay? So, what did oxygen do? How many, first of all, what did the charge do? Let's talk about that first. Oxygen did what with 2 electrons? It gained 2. But how many gained 2? 2, agreed? Yes? So 2 gained 2 electrons. Does the right side really matter that there was 2? No, it doesn't really matter, right? Because it's all based on the left side. So yeah, it's changing, but still it's the same idea. So this is the total of how many electrons? This is 4 electrons. So 2 gain electrons for a total of 4 electrons. Are we good so far? Yes.
Okay, so like, why don't you do anything with sulfur?
We're not. That's why I asked, are we good?
Yeah.
So we're not good, right?
Yeah. No.
Because sulfur also does something.
Wait, we're not doing anything with sulfur?
We have to.
We are.
Sulfur,
Are we going?
right? Sulfur went from a 2 minus to a 4 plus. Agreed? So sulfur's also doing something.
It's changing even more.
Okay, what does sulfur do? Did not gain. It lost 6 electrons. Sulfur lost 6 electrons.
Holy moly.
So hold on, okay? Stay with me. So here I've lost 1. Yes?
Yeah.
You guys with me?
Yeah.
Here I have gained 4 and I've lost 6. So I know that I'm going to have to eventually make these balanced. Agreed? So any ideas for what the next step would be? Brendan?
Because it's like an odd number of like lost electrons, you multiply the 1 by 2.
So which one do you want to multiply by 2?
Iron.
This one?
Oh, no. The first one.
What do you mean second oxygen?
Like the other part of the branch thing.
It's just showing that they're both changing equally. So this is going here, going here. What'd you say? 2 to the first iron. So I lost 1 here.
We
Agreed.
make it 2 lost 1.
Why is it 2 lost 1? Only 1 lost 1. Agreed?
Yeah.
Yeah.
I'm just seeing if you guys have an idea for the next step.
I'm still confused on that.
All right? No, any ideas yet?
I'm still stuck on the oxygen.
No ideas.
Yeah.
Where do you want to put something?
A 2 in front of the
On.
FE.
2 here.
Yeah.
And 2 in front of O2.
Now let's think about that.
Can you put a 4 in front of
I
something?
take it back.
All right, let's think about this. Is this oxygen going to balance at an odd number?
No. So you
No. What do I know I'm going to have to put in front of this compound most likely? I'm most likely going to have to put a 2 here. Agreed?
Yeah.
Yes? So that would be my first step. But if I put a 2 here, what's going to have to go here?
4.
A 4. Agreed? Yes? If I put a 4 here, what am I doing to these electrons? I'm multiplying them by times 4 for a total of 4 electrons. But what am I also doing to these electrons?
4.
Times 4
That's a lot.
for a total of
24.
24 electrons.
Let's go.
How many total electrons did I lose? 28. What times 4 gives me 28?
7.
Times 7, yeah, it gives me 20 electrons. So what coefficient goes here?
7.
7. Finish it by inspection.
Wow.
What coefficient's going to go here?
4.
4. That is balanced.
Wait, I'm so lost. You just got worse.
I know.
Where'd I get 28? I got 28 from 4 plus 24. These oxygens over here, it's not important that there's 2. It's all based on what we start with.
So why didn't
Okay.
you add the 4 at the top?
What do you mean at the 4 at the top? When I put 4 here, that's only affecting these two things.
So the right side.
So you just took.
The right side is unworthy. The right side is what's happening. We only care about what we're starting with, the initial conditions.
So how do you know not to add the like? Because you have the 2 gains, 2 electrons.
Yeah.
Did you
This is
only
good.
do the? You only did the lost because they're lost ones.
What do you mean I only did the lost?
Because you did 24 plus 4, so it goes 28. That's just, you're just adding the lost ones to get that, and not the gain.
Yeah, I know that my lost has to equal my gained, right?
I think I'll just do that.
So I have a total of 28 lost. I know I have to gain 28, so 4 times 7 is 28. This is probably, I'm trying to give you guys everything you might see.
No, this is good.
This would probably be the hardest one you'd ever have to do.
Oh.
Like, okay? They're
Well,
not,
we
I
don't-
just want to try to give you guys examples of different ones.
Yeah.
That's
All right?
It's just
So,
conceptual.
what was oxidized?
Oxidized is lost.
Yes.
sulfur and iron.
Iron and sulfur were both oxidized. What was reduced?
Oxygen.
Oxygen was reduced. How many total electrons were transferred?
28.
28 electrons transferred. 28 electrons transferred. Let's do another one. Ca3. Oh, get ready for this, guys. Parentheses.
No.
PO4 2
No more.
plus SiO2 plus C yields CaSiO.
What does that say?
What does what say?
Why do you sound so excited?
What does what say? SiO2?
Oh, that's an I? Okay.
Yeah, SiO2. CAS obviously
It's like one of the 2 dot
You mean a colon?
Yeah.
plus
I can't.
CO plus P4. There's your whole equation.
So,
So long.
That's Si. Silicon. Silicon dioxide. Silicon dioxide.
I no longer like this. This was kind of fun until this part.
Ah, I know. It's the worst.
It's always that last one with me, so it's kind of fun.
This one's actually easier than the last one.
no.
Yes, it is.
No.
Yes, it is.
There's more work, therefore.
Shall we work together?
No.
Okay, assign it. Assign your charges.
I don't. I hate this more than I hate soy. I literally
do our charges
need,
so we
like,
don't mess
4.
up like
Yeah, do your charges, and we'll do a check step there. The hardest thing about this is adding and making it equal 0. I'm telling you.
Are we going through all of it or just doing the?
Do your charges, then we'll check there, then you can keep going.
I am so dumb.
Break down crying in the middle of class.
how do you know?
Do you use the thing for the
Oh.
PO4?
You know carbon? What?
Do you use the thing for PO4?
What is that?
What thing?
This is the thing.
Nope, you just follow the rules.
Okay.
Follow the rules.
Like the book from Fairly Odd Parents, like this is the rules on it.
That just can yeah.
Is it just 12?
What are we writing 12 on?
Jake said
I did not write 12.
Okay.
Yeah.
We're not writing 12 anywhere for any oxidation number. What was that?
Is this a sign?
Do we have oxidation numbers assigned yet?
No.
Okay.
Not even
All right, we'll pause.
That's how I feel.
Yeah.
Wait, how do you do PO4?
The hardest part
It's PO4.
is adding and subtracting and making it equal 0.
I like so much right now. I'm like, this is like a thing.
You are in AP chemistry.
Yeah.
Many of you are in AP calculus, AB or BC.
I don't know what math I need to do.
I don't know what.
Like I know calcium and silicon are something,
Yeah.
but I don't know what they are supposed to do.
Oxygen has what charge?
Two.
2 minus. Calcium has what charge?
Oh, that's individual.
Calcium has what charge?
No. 2 plus.
Wait.
2 plus.
So you did use the sheet.
No, I didn't. I used the rules.
Yeah.
Calcium is an alkaline metal,
Yep.
always plus 2.
Uh-huh.
Agreed?
Yeah.
How else would you figure this out?
That's good.
So,
I put 3 minus.
what?
Yeah, I had
It
3
is,
minus.
but here it's just in a compound. You could also figure it out with that. It'd be the same thing. You could have figured out the overall charge of PO4,
Oh.
but it's just easier to do it like this. So I have 2 times 3 is,
6.
well, let's do the negatives first. I have negative 2 times 4 is negative 8. Negative 8 times 2 is negative 16. What's my positive?
6.
Positive 6. Negative 16 plus positive 6 is negative 10. So what do I need to get to delete that? Positive 10. What times 2 will give me positive 10? Plus 5.
That's pretty.
This is not hard.
I want to.
All right? This is not hard.
That's what you use. Find what you can.
Yes.
And then the rest.
You
is
find
fine.
what you know, and then you just do the rest, make it equal 0.
Okay.
Oxygen, 2 minus, so silicon has to be a 4 plus.
I got that.
Carbon is elemental form. Oxygen is 2 minus. Calcium is 2 plus. So this silicon's going to be plus 4. Plus 4. Oxygen is always a 2 minus. So this carbon is a plus 2. P4 is elemental form.
I got that one.
Elemental form. So, like I said,
Yeah.
adding and subtracting
It's like it's not.
integers are the hardest part of this. Did calcium change?
No.
Did phosphorus change? Okay, let's do phosphorus. Here we go. Let's find its buddy over here. What did phosphorus do? Gained. How many gained 5 electrons?
1, 2.
That distributes. Agreed?
Yeah.
How do we know what's gaining and what's losing?
From a plus 5 to a 0. That means its charge. That means its charge got more negative. Agreed? In order to become more negative, you have to gain electrons. It's backwards thinking. Right?
So, like if it gains charge, it actually
If you're gaining charge, you're being reduced.
over.
Right? Gaining is reduction. That's why we talked about that. It just takes a little bit of thinking. So, 2 gain 5 electrons for a total of 10 electrons. 10 electrons. Beautiful. What else is changing? Carbon. Carbon is changing. What did carbon do?
It lost 2.
Lost 2 electrons for a total of
2.
2 electrons. Okay. Well, are you guys writing in pencil or pen?
Pencil.
Good.
Oh,
So, 2 times what will give me 10?
5.
So I'm going to put a times 5 for a total of 10 electrons, which means this is going to become what coefficient? 5. Going to become a coefficient of 5. So, I'm looking, my electrons are balanced. Agreed?
Yeah.
Yes? What is the problem?
Balance.
How many phosphorus do I have here?
4.
How many do I have here?
2.
2. So what coefficient has to go in front of this compound?
2.
2. Well, that changes this electrons to how many? 20. So 10 times 2 is? 20 electrons are now lost. So what do I have to do to this number? Multiply it by 2. So now I have 20 electrons, which means this coefficient has to change to 10. That changes to 10.
I don't like that.
The beautiful thing is, if you, what? The beautiful thing is, if you've done it correctly, everything else is just inspection. 10 carbons here, what coefficient is going to go here? You know it's going to be 10. 6 calciums here, so what coefficient is going to go here? You know it's going to be 6. And that, I have 6 silicon here, what coefficient is going to go here? That's balanced. So once you balance, your electrons, everything else is just going to work out beautiful.
I feel like that's a lot.
It's a lot.
So you get the electrons balanced, and then
Everything else by inspection.
okay.
Yep. What was reduced? Or what was oxidized?
The carbon.
See, like,
Carbon was oxidized.
I understand it, but I can't replicate it.
This next one you'll get it. What was reduced?
Phosphorus.
Phosphorus was reduced. How many total electrons were transferred? 20. 20 electrons transferred. Okay, I think you'll get this one by your own. Here we go. K2 Cr2O7 plus S8 plus H2O gives me SO2 plus KCr parentheses OH4.
Okay.
I think you guys can do this one. All the way on your own. All the way on your own. The looks on your faces are incredible right now. I see everything from, I can do it, to disgust, to zero confidence. It's awesome.
This class is very humbling.
This is not hard. And like once you guys practice this, it's gonna be like super easy points on the test next week.
Super easy ones.
Next Friday. We will test next Friday, I'm pretty sure. I feel 98% tested next Friday.
And that's
Makes
when
me
the
like
homework will be due.
feel violent. Like I
Homework will be
really
due next Friday.
Is that still ahead of last year's?
We are doing incredible.
Of course, of course.
Seconds to look at your electrons and then figure it right. When you look at your total electrons.
Okay.
No, thank you.
No, that's good.
So we're getting there.
We can use calculators.
Sure.
I think there was a lie when you said this would be the hardest of our problems. Still.
Wait, what do you mean the hardest of our problems?
Like the first one that we did,
I think that first one with the 7 and the, I think the 28 was the hardest one. This is easy.
Dude, I want to get
I'm going to start my work.
Vince Young.
Oxygen, 2 minus, potassium, plus 1.
Yep.
So this chromium is
6
plus 6. Questions on that?
Good start.
Sulfur is
0.
elemental, 2 minus, 1 plus.
Yep.
2 minus, this one is
4
4 plus. Okay, over here, potassium is always a 1 plus. Oxygen's a 2 minus. Hydrogen's a 1 plus. So what do you figure out for chromium here? 3 plus.
I actually got that right.
Why is that 3 plus? Because I have 1 positive, right? 1 positive times 4 is, 1 times 4 is 4. 4 plus 1 is
Oh, shit.
5. 5 plus negative 2 times 4. So 5 plus negative 8 is negative 3. So in order to make it 0, chromium has to be a plus 3. What changed? Did potassium change? No, chromium did, right? What did chromium do? 2 gained 3 electrons for a total of 6 electrons. What else changed? You almost know it's going to be the elemental one, right? So sulfur did what? How many lost 4? 8 lost 4 electrons for a total of 32 electrons. And then on the board I wrote least common multiple. The least common multiple between 32 and 6 is 96. So 32 times what gives me 96?
3.
Times 3, that gives me a total of 96 electrons. So what coefficient goes here? 3. And 6 times what gives me 96? 16. Times 16 gives me a total of 96 electrons. So what coefficient goes here? 16. So if I have 32 potassium here, what coefficient has to go here? 32. And I have 24 sulfurs here, so what coefficient has to go here?
3.
24. 24 sulfurs here.
I got it. I
Okay.
said the wrong thing.
So 24 here. 24 here. And then the last thing is just by inspection. How many H's do I have on this side?
128.
32 times 4. I'm sorry. 32 plus, no, I have 32. 32 times 4 is 128, right? So what times 2 gives me 128?
64.
64, that's balanced.
That is.
I like this.
That would be virtually impossible to balance regular. All right? You've got to use the redox method for that. Got to use the redox method for that.
Yeah, no, I feel it. I feel it.
I got to 96 and I was like,
I got the process down.
Were you close?
I got it.
I got to the third.
I got to 96 and I just didn't know where to pull it.
Yeah.
All right.
I have the
What
process.
if we had a net ionic situation?
Well,
All right? What if we had a net ionic situation? So if I had something like this, Cr2O7, and that's going to be a charge of 2 minus, plus I minus 1, plus H plus, yields Cr plus I2 plus H2O.
that's a boy.
So, do I have a charge on I minus?
Yeah.
H,
Yeah.
yeah. Chromium. I should have given you, I'm sorry, I have to give you the charge of that, 3 plus. You'd have to know the charge of that. Because I don't really have, that's in that ionic equation. Okay? So here we go. This whole thing has to have what charge? 2 minus. Oxygen's what charge? 2 minus.
14.
So 2 times 7 is negative 14.
Yep.
All right? So I need to have it a charge of negative 2. So I have to add negative 14. I have to add 12 to that. So what is this going to be?
6
Plus 6.
Where'd you get 12 from?
So the overall compound has to be a minus 2. 2 times this is negative 14. I need it to be a negative 2. So in order to get a negative 2, I have to add positive 12 to that. So when you're dealing with the charges already, it tells you what charge you're trying to get it to. Good, 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 good. I2 is elemental form. Oxygen is a 2 minus, hydrogen is 1 plus. Finish it. I think we're going to finish these notes today. Got 5 minutes left. We're going to do it. You guys do your work. I'm going to do my work.
Okay.
You guys have what I have so far? Yes?
Yeah.
This is basically my redox part. Everything else is by inspection. Agreed?
Yeah.
What so I've got 7 oxygen here. Agreed?
Yes.
So am I going to be able to get, what coefficient has to go here?
7.
7. Which gives me how many hydrogen? 14. So what has to go here?
14.
Balanced. Oh wait, 2 here. The chromium needs 2. Did you guys get that one?
Yes.
Good. All right, what was reduced? Chromium. What was oxidized? Ion, right? Yes? Okay, last one. Last one. Oh, shoot, we don't have time. We'll do the last example tomorrow. Actually, no, I'm going to give this to you guys for homework.
What?
Do this one tonight on your own. Cr OH parentheses 4. That whole thing is 1 minus. Plus H2O2 plus OH minus 1 yields CrO4 parentheses 2 minus plus H2O. So there is one to try tonight on your own.
That's certainly a problem.
Cr parentheses OH4, that whole thing is a 1 minus. CrO4, this whole thing is a 2 minus. So try that one tonight on your own. Try that one tonight on your own.
It's easier than you think, but it's still pretty hard.